This video is about modeling a situation using exponential growth and decay and predicting future outcomes using exponential and decay. So a quantity is growing exponentially if it increases by the same percentage in each unit of time. This is called exponential growth. So in exponential growth, our equation is y equals a times the quantity 1 plus r to the t power. A is going to represent our start value. R is going to represent our rate, that is always as a decimal. And T is going to represent our time. So a couple of things before we do some problems. Make sure that when we are rounding, if we are using dollar or years, we're going to round to the nearest hundredth, which is 2 decimal places. And if we're using units such as people or animals, we're going to round to the nearest whole number. So let's look at a situation here. You deposit $500 into an account that pays 8% interest each year. Write an exponential growth model for your account balance. So we have y equals, we're starting with $500 in our account, times parenthesis 1 plus, because we're adding. Now, we have it as a percent. So 8%, we're going to move our decimal place 2 places to the left, and that becomes 0.08 to the t power. Now we can also write that as y equals 500 times 1.08 to the t power. So now we want to find the balance of the money if we invest for a certain number of years. So we're going to take our number of years and we are going to substitute into either equation for t. So I'm going to use the one where the percent has been added. So we have y equals 500 times 1.08 to the power of 4. So in our calculator, we're going to type 500 parenthesis 1.08 close parenthesis. We're going to use the caret, which is above the division sign, and our exponent, 4. So this would get us 680 point, and then we have to round. So if I'm rounding to the hundredth, the next number is a 4, so I stay the same. So we would have y equals $680.24. Now we're going to do the same thing with 15 years. So now we have 500 parenthesis 1.08 close parenthesis caret to the 15th. And if I round, so we have y equals 500 times 1.08 to the 15th. That equals $1,586.08 when we round. Let's look at another example. So in 2010, the salary for working at a summer camp was $1,800 for the entire summer. Each year you return to work, your salary increases by 5%. Write an exponential growth model for the salary at the day camp. So we have y equals, your salary starts at 1,800, parenthesis 1, plus we want to add our percent. So if we have 5%, we're going to change that into a decimal, which would be plus 0.05 to the t. Or we could write it as y equals 1,800 times 1.05 to the t power. So what is the salary in 2012? And we are starting in 2010. So from 2010 to 2012, that is 2 years. So we're going to put 2 in as our exponent. So we have 1,800 times 1.05 to the second power. So we type that in our calculator. And that gets us $1,984.50. What would the salary be in 2015? So in 2015, that is 5 years. So we have y equals 1,800 times 1.05 to the 5th power. So that would get us $2,297.31. Let's look at one more example with exponential growth. So in 2005, a population of 20 rabbits was released into a wildlife region. It was observed that the population increases by 45% each year. Let t equals 0 represent 2005. So write an exponential growth for the rabbit's population. So y equals, we start with 20 rabbits, parenthesis 1 plus, we have 45%. So if I move my decimal 2 places, we get 0.45 to the t, which would be y equals 20 times 1.45 to the t power. So we want to figure out how many rabbits are there in 2014. So from 2014 to 2005, that was 9 years. So we have y equals 20 times 1.45 to the 9th power. Now, because we're talking about rabbits, we want to round to a whole number, and we cannot round up in this case. We're not going to follow normal rounding rules because it's rabbits, so we're not going to have a partial rabbit walking around, and we can't round up, so this would get us 566 rabbits. So now let's switch gears and let's look at what happens when we are decreasing. So a quantity is decreasing exponentially if it decreases by the same percent in each unit of time. This is called exponential decay. So the difference in exponential decay is that it's the same equation, but instead of plus r, it's going to be minus r. So a is still going to represent your start value. R is still going to represent your rate as a decimal. And t is still going to represent your time. So in number 4, you bought a used car for $18,000. The value of the car will be less each year because of depreciation. The car depreciates at 12% each year. So in our exponential decay, we're going to have y equals, the start value is 18,000 times 1 minus our percent. So if our percent is 12, we're going to turn that into a decimal of 0.12 to the t, which would get us y equals 18,000 times 0.88 to the t power. So in decay, the decimal in our parentheses is always going to be less than 1 now. So same thing though, to figure out the value, we're going to plug them in for t. So if I want to know the value of the car at 4 years, y equals 18,000 times 0.88 to the 4th power. So we have 18,000, parenthesis 0.88 to the power of 4. And that would round to $10,794.52. And then at 15 years, we have y equals 18,000 times 0.88 to the 15th. So we put that into our calculator. Our car value would be $2,645.53. So let's look at another equation. In 1999, Tommy decides to invest $4,000 into the stock market. Each year then, the stock depreciates at 2%, right? The exponential decay model. So we have y equals, we start with $4,000 in the stock market, times quantity 1 minus, we're going to take 2%, turn it into a decimal, so it'll be 0.02 to the t power, which simplifies to y equals 4,000 times 0.98 to the t power. If Tommy decides to leave his money, what is the value of his stock in 2005? So he started in 1999, so in 2005 that would be 6 years. So we're going to put 6 in for t. So we have 4,000 times 0.98 to the 6th power. So he would have a value in the stock of $3,543.37. So let's look at one more example of exponential decay. A town's population in 2011 was 54,345 people. A big manufacturing plant closed in the district, and the population decreased by 3.6% each year as people left to go find other jobs in other towns. Let T represent 2011. 11. So in our exponential decay, we have y equals, we start with 54,345 people times 1 minus, now 3.6, we're going to move that decimal over. So this times we have 3 numbers after our decimal. So minus 0.036 to the t. So we get y equals, I'm going to use the calculator to subtract 1 minus 0.036. So we get y equals 54,345 times 0.964 to the t power. So what was the population in 2013? So from 2011 to 2013, that is 2 years. So we're going to put 2 in for t. Y equals 54,345 times 0.964 to the second power. So that's going to round, and because we're doing people, remember we're rounding the whole number, so we're just going to cut off our decimal because we can't round up for people here. So we have 50,502 people. The last thing we're going to look at is if the function is a decay or growth, and what is the rate. So if it is a growth, that means it's going to be greater than 1 in the parenthesis. So growth is going to be greater than 1, and decay is going to be less than 1 parentheses. So in A, we have y equals 45 times the quantity of 0.96 to the t power. So the number in parentheses is less than 1, so this is a decay. To figure out the rate then, if it's a decay, you're going to do 1 minus that decimal. We get 0.04. We're going to turn that into a percent. So when I move my decimal 2 places, that turns into 4%. So we always want to write our rate as a percent. So we need to convert our decimal. In B, we are greater than 1, so this is going to be a growth. So now I want to take that number and subtract 1 from it. So we have 1.05 minus 1 equals 0.05. We move the decimal 2 places, and we get 5% as our rate. C, we are less than 1 again, so this is a decay. So we're going to do 1 minus 0.07, which gets us 0.93. If we move the decimal 2 places, that gets us 93%. Our last example, 1.6 is greater than 1, so this is growth. So we're going to take that and subtract by 1. That gets us 0.6. If I move 2 decimal places, I have to add a 0, so that gets me 60%. So remember, when you're trying to find your rate, if the rate is less than 1, you do 1 minus that rate. And if the rate is greater than 1, then you do the rate minus 1, and always convert it into a percent.